Welcome to this video on the BETTED Toolbox. In this presentation, we will focus on the LCA Toolbox. After a brief introduction to the project, the video will highlight the tool's key features and provide an example of its practical use. BETTED stands for Boosting Energy Transition of the Dairy Value Chain. It is a European project that focuses on facilitate companies, especially small and medium SMEs, belonging to supply chains in the dairy sector to foster the market uptake of energy efficiency measures, including the use of renewables and the deployment of heat pumps at the value chain level. Moreover, the project will also significantly contribute to the reduction of fossil fuels dependency, fast-forwarding energy transition. For further information on the project, please also visit our project homepage at www.bettedproject.eu. The mission of BETTED is based on three pillars. 1. Establish a capacity, building program and community to transform organizational energy cultures, enhancing skills and knowledge in sustainable value chains, thus promoting energy transition for companies. 2. Implement tailored and easy-to-use tools engaging companies operating in the same value chain. 3. Provide policy, just regulatory recommendations aiming at speeding up the energy transition. Let's move to LCA. Life cycle assessment is a technique to assess the environmental impact of a product life cycle. In life cycle assessment, all stages of a product's life are taken into account, such as material processing, product manufacturing, distribution, use of the product, and end-of-life operations. Life cycle assessment, LCA, has been standardized, with ISO standard 14044 providing the main guidelines for conducting an LCA study. For more information about LCA, refer to that source. Let's now make a focus on the key aspects related to the tool. This tool facilitates the life cycle assessment, LCA, of cold supply chains with an emphasis on the dairy sector, enabling the evaluation of their environmental performance. The LCA impact categories encompass three key areas of environmental assessment: global warming potential, GWP, cumulative energy demand, CED, and water use, AWARE method. The global warming potential, GWP, is based on the 2013 method developed by the Intergovernmental Panel on Climate Change, IPCC. This method evaluates the impact of greenhouse gas emissions by measuring the equivalent kilograms of CO2 released over a 100-year timeframe. The cumulative energy demand, CED, is determined using EcoInvent version 2.0, as implemented in the Life Cycle Assessment Tool, CIMA Pro 7. This metric quantifies the total energy consumption associated with raw materials, providing insights into the energy intensity of a product or process. Lastly, the water use, AWARE method, is applied to assess water scarcity risks, following the recommendations of the International Working Group, WULCA. This method estimates the likelihood of water deprivation in a given area, emphasizing the potential impact on both human and ecosystem water availability. By analyzing these three impact categories, the LCA approach provides a comprehensive evaluation of environmental performance, supporting more sustainable decision-making across supply chain. Let's take a closer look at the LCA BETTED tool, an Excel-based solution distinguished by its bluish color. The tool consists of multiple spreadsheets, each serving a specific purpose to streamline life cycle assessment LCA processes. The first page in the tool is the info sheet, which provides essential information about the tool and its functionality. A key feature of the tool is color coding, which helps users navigate the input fields efficiently. Green cells are the only fields that users should modify, while gray cells contain values transferred from other sections of the workbook or calculated based on the user's input. You may also notice that only certain cells are accessible. This intentional design minimizes input errors and simplifies usage. Next to the info sheet is the input sheet, which begins with an introduction. This is where you'll input your data. Depending on the information required, some fields will be numerical, while others will have drop-down menus for easy selection. The input sheet allows you to define the supply chain for the product under consideration, including transportation methods, storage in the cold chain, and waste occurrence. Additionally, the input sheet features an individualized product section, an optional feature where users can enter their own product if they have specific data on global warming potential, Cumulative energy demand and water demand. If you prefer to use the existing EcoInvent 2.0 database, simply select No Product from the drop-down list and enter 0 in all other fields. You can now begin tracking the product lifecycle from the raw material supplier to the retailer. Once you have selected a product from the default list or entered details based on individualized product information, the temperature levels for transportation and storage will be automatically set, along with all associated environmental impacts related to raw material provision and transport. For instance, let's consider cheese. You will start by inputting the batch amount, excluding packaging. Then continue by entering transportation details from the supplier to the producer. This step covers raw material transport, including vehicle type, such as refrigerated transport, travel time, and transported quantity. In the production section, you will input details about the finished product, ready for distribution and consumption. Here, you will enter data related to packaging, annual production rate, storage conditions, and more. You will also need to specify energy consumption, whether sourced from the grid or alternative energy, water usage, and the required amount of refrigerant in the warehouse. Data entry continues with information about waste and wastewater disposal. If operating within a local transportation system, simply skip sections 3A, 3B, and 3C and proceed to step 4. As you move forward, you will input transportation details to the distribution center, following the same structure. The distribution center sheet mirrors the processing unit data, allowing for consistency in data entry. The final wholesale stage completes the supply chain tracking. The what-if sheet provides an estimation of life cycle costs related to material flows, such as energy, fuels, and CO2 emissions, but excludes capital and labor costs. You can also indicate potential savings from implementing energy efficiency measures within specific supply chain stages. A sensitivity analysis sheet presents a comparative assessment of life cycle costs with and without energy efficiency improvements. Once all relevant data is entered, the final results sheet provides a detailed environmental performance analysis, including potential impacts per functional unit, such as the kilogram of product at the retailer stage, including packaging. The results are presented for each stage of the supply chain, making it easy to identify which process has the highest environmental impact. This allows businesses to pinpoint energy efficiency measures that will yield the most significant improvements. That concludes our presentation of the LCA tool within the BETTED project Toolbox. If you're curious and want to explore further, additional tool videos are available on our channel. Thank you for watching.